We've asked these speakers to not necessarily use charts if they don't want to, but to communicate in about 10 minutes one key idea in the space that we've defined for this meeting. I get the job of kicking this off, and we'll try and keep this on track, hard as that is going to be, I'm sure. So please take your seats. These are going to be very quick talks. We're not going to have questions, but we will have the panels in the afternoon when we can go deeper into these. So let me just start by just framing my own view of what we're looking at here. So this is my own personal point of view on the relationship between information and a city. That I think of a city as a collection of processes. Some of these are urban processes, running a train system, running an electrical utility perhaps. Some of them are commercial processes, running a store, running a manufacturing business, and some of them are personal processes. How do I get food for the week? How do I keep my house or my apartment warm? They are rooted in the topology, the natural environment on which that city is based. That defines the geography, it defines the climate. It may, with some luck, still define the fauna and flora that you find in the city. But it's also very much obviously dependent on the built environment, the infrastructure, public and private, that's been constructed there. And which is intended to support the needs of the inhabitants. It doesn't exist for its own good. It exists to enable people to live and work and enjoy their lives in that city. Processes inherently consume resources of some kind. That might be a physical resource, water, energy, can be food, can be a kind of virtual resource. It may be capacity in a transportation system, in a road system. That can be consumed repeatedly in the case of that kind of utility. And they produce outputs. Some of those are economic outputs, social outputs, the desirable outputs of that process. In many cases, they also will have byproducts that may be less interesting, or sorry, less desirable. And one of the things that I have wanted to see work on for a number of years is, in principle, one could model those processes at a very detailed level. And with the kind of data that Steve Koonin was talking about earlier on, one would have the basis for calibrating those, what will be very complex models. But all of those interactions between people and these processes in the city are essentially mediated through some kind of information. When I get out of bed in the morning and find my way to work, I make a series of decisions about what processes to exploit in order to get myself from bed to work. How do I make those decisions? How do I make those choices? And I think one of the things that's interesting about a large city is the number of different choices that it gives me for each of those decisions and the way in which I can discover those choices. So that's my own perspective on cities and information. What we're trying, I think, to do in terms of enabling this information to have an impact is looking at generating a set of systems, machines, that we would like to then employ, among other things, to make those processes as efficient as possible for the individual citizens, as well as for the people who are charged with managing those processes. And those are efficiencies in terms of the overall safety of the city at a collective and individual level, how that city is able to exploit its infrastructure for economic development, how it is able to reduce costs of operation, to reduce resource consumption, probably more in the future, how it is able to reuse some of the byproducts from those processes to develop more closed systems, how I am able to make those decisions, how am I able to discover the choices that a city offers me, and find what is on any given day the most interesting way to get from bed to work, for example. And in the longer term, how do we make that city resilient against both acute impacts? I'm conscious here that we are very close to one of the fault lines. New York City, the city is becoming conscious that much of it lies at low level, and a storm surge of a couple of meters would flood significant areas of New York City, for example. How do we exploit information to those kinds of ends here? I think part of our debate here today, in the next day or two, will be on how should that information be generated and collected and managed and made useful. And one of the dimensions along which we can explore that is between inherently centralized systems and inherently distributed systems. Some of you may know Anthony Townsend, the Institute for the Future. Anthony's written a number of times about his view that, that it was more desirable to make these systems as distributed as possible versus what I might think of, if you forgive me, as the IBM approach, which in many cases involves centralizing information so that you can aggregate it, compare different data sets, and do deeper analysis on them. The metaphor I'd suggest for that is, and it's only a metaphor, it's not a model, is to think of how the human body, or in fact the mammal body in general, manages this kind of problem. It actually has multiple approaches to that. There are some processes in human animal that are inherently centralized because they require a significant amount of compute. Vision is one, reasoning is another one. And so we centralize in our brains. We commit some 20% of our total energy capacity to running that brain, and we have a huge network of sensors that extend throughout the body that bring information into that place. But there are other systems in the body that are inherently diffuse, distributed. The immune system, which is inherently distributed throughout the body, is another way that the body deals with the problems of defending itself, which can occur, of course, anywhere within the system itself. So my thought on this is as a metaphor that we actually need both the ability to centralize some activities as well as to distribute them. Distributed systems have an inherently advantage over centralized systems in terms of resilience, for example. So one of the, as we were preparing this, my views on this symposium were that we would look at some of these dimensions. This distributed, centralized dimension is only one of them, that we would collectively, through the panels and through the workshops tomorrow, explore in specific contexts what are those dimensions and what do we feel about how to approach it, which may vary from city to city. Highly dense cities may exploit information in ways that are different from very diffuse systems, very low-density systems. And that out of what we would do tomorrow is we will have some sort of maps, sketches of how information flows, where it originates, where it can go to, where it can be most useful, how it gets combined with other kinds of information. And so one of the outputs from our thinking tomorrow would be some early examples of how the many sources of information that Steve talked about earlier on can come together to serve different kinds of purposes. And in the couple of days we can only look at a very small set of those. So that's my own view and my introduction to what I see as doing over the next 24 hours, 30 hours or so here. So at that point, I'm going to stop, actually stopping a little bit early. For those of you who are speakers, Nick DeMonchaux has a big clock down here on his iPad that tells me exactly how many seconds I have left. But I'm going to close at that point and invite our next speaker, who is Mark Baker from Esri.
Thank you, Colin, for that introduction. Mark Baker from Esri. I'm very happy to be part of the Urban Systems Collaborative and helping the collaborative think about the urban environment. And as you can probably tell, coming from Esri, we like to bring the geospatial dimension to the discussion. And that's really, as we go through these lightning sessions, we're going to be looking at the urban environment through different lenses. And my lens tends to be the more geospatial lens. And this topic, this 10 minutes, is really meant to think about how the many stakeholders we have in cities start to think about collaboration and collaborating through geography. There are many cities and many stakeholders in the urban environment that I'm sure are represented in the rooms. There are the private contractors, there are the architects, there are the city operators and managers, there are the developers, the transportation organizers, and so forth and so forth. And these stakeholders all look at their particular domain through their particular lenses. They all look at it as their particular challenge, and it's a question of how we bring all those elements together in one combined environment, which is where we'd like to suggest that geography is one of those tools, is one of those mediums in which we can bring these different stakeholders together. In many ways, it's about the platform. It's about establishing some common platform that allows these different stakeholders to come together and have a dialogue. That's really what seems to be critical for us. And what we postulate is that, what we have the idea of is that geography is what's consistent through all these different stakeholders, and it's the location that really ties that all together. So to us, cities are a confluence of geospatial information, a natural confluence of geospatial information. Through the previous speakers, we already started to look at big data, but big data on its own, tied to geography, becomes important data for us. We look at data that many organizations hold in their own personal archives, on their own personal machines, maps, spreadsheets, data that's harvested from social media environments, and data that's harvested from different sensors, not just the satellite sensors and the airborne sensors that provide thematic information, DEM information, LiDAR information, and so forth, but on the ground local sensors, building sensors, traffic sensors, and so forth. Bringing those all together into a common platform is one way we'd sort of like to think about how the urban system can actually function as a more complete system. And for us, what we really want to think about is how that system then can be alive and can actually function in a cloud-based environment. So that very dynamic platform that allows different demographics, different stakeholders to come together in that collaborative environment and start to work together in their particular domains. Now, this is actually happening now. So this is not something new. This is not something that we're sort of postulating as an academic exercise. Geospatial information is the platform for many examples of city environments, urban environments. And just a couple I wanted to share for you in this session, and we'll explore a few more in the sessions for the later in the day and tomorrow. But already looking at the planning aspects of cities, geography has been used at the local level for subway planning, space planning, and so forth, looking at how boundaries and school districts are coming together to serve those communities, all the way through to the land zoning and the land use issues that many cities face. The physical ownership of land is very important. Having records of that land, allowing us to understand the parcels, who owns the parcels, what is the parcels designated for. Geography has a very important role to play in bringing that information into our urban system. Transportation. Transportation, I think someone mentioned in the audience, they come from that transportation area. Geography is an inherent part to building smart transportation networks that allow us in public transit in different parts of the country to come together, designating school zones, school bus zones, routes, and so forth, and building apps that allow us to take those maps and that information onto mobile devices as citizens. Smart utilities, smart telecommunications, a very important part of our cities as we start to plan for how the citizens adopt mobile technology in their day-to-day life. Singapore, for example, has a cell phone usage of 150%. So, more Singaporeans have more than one mobile device in that city, and they consume geospatial information. They consume information about their city, information from their government on mobile platforms. And planning for that type of cell phone usage, smartphone usage is extremely important. Law enforcement. Allowing our law enforcement organizations to be able to respond to incidences, community issues, predictive analysis is part of how we want to create a smarter city, a smarter environment that's safer for us all. And again, geography is that underlying principle of putting together a common operating picture that's important for decisions to be made for the protection of the citizens. Natural disasters. Been told this morning that this building is built on a fault. So if we do start to feel the building shake, I was told to get under a table. But in all seriousness, planning for natural disasters is an important part of what cities need to actually understand, not just earthquakes, but also natural disasters from hurricanes, tornadoes, and so forth. Geography provides us the pre-disaster and the post-disaster vision or view of the world, and allows us to make intelligent decisions and inform citizens about how the government or how other organizations are responding to the citizens' needs during those disasters. And we're going to take some of these themes into the breakout panels later on today. And finally, one of the newer sort of developments is how we start to then consume and visualize that information, using a lot more of the 3D environment, built environment, moving away from 2D geographical representations into 3D representations is becoming more and more prevalent in our world. So everything from buildings and campuses, that we've got Rochester, New York here as an example, through to Hawaii, parts of China, parts of Indiana, Croatia, Paris. The 3D viewer, the public viewer, is available in parts of China on mobile devices, as you see in the top left. So being able to give the citizens that geographical perspective based on full 3D features as they see it in reality is one of the most important progressions that we need to observe and take advantage of as we think about our urban systems. So ultimately what we're suggesting in this talk is that geography really starts to break down those barriers. Those barriers may or may not be severe, depending on how local organizations in the city collaborate already. But what we postulate is that geography allows us to sort of strip away some of those barriers and start to fuse data information together into a common platform that then allows us to make some intelligence decisions about what to do in our urban environment for the future. And with that, thank you very much.
Got it? I hope so. Hold on, John McCabe. Get rid of the wireless network before anything else comes up. Page up and down the top of it. What was it? Page up and down there. Okay.
All right, thank you. Well, it's great to be here at UC Berkeley. I did not attend UC Berkeley, but my wife did. Anyway, Lifecycle Resource Quest. So I'm here to talk about city operations, and in talking with Yuri about what might be interesting for the collaborative, we said, well, let's take a look at one specific data flow, one specific process. So I'm going to look at what happens if somebody asks the City of Oakland Public Works Agency to do something. So this might be fix a pothole, pick up illegal dumping, take care of some graffiti, something like that. So first, a little background about the City of Oakland. We're a medium-sized city. We're one of the 10 largest cities in California. We're extremely diverse. Actually, Brown University just put out a study looking at the most diverse cities and least diverse cities in the country. Basically, all the least, well, 5 of the 10 most diverse cities are right here in the Bay Area. So it's a pretty exciting place to be. For California, being a 150-year-old city, we're pretty old. Our infrastructure is pretty old, and that is a challenge for us because our infrastructure needs a lot of work that we don't necessarily have the resources to do. In public works, we maintain basically everything that you see every day, but maybe don't notice. So we have the street trees, we have the streets, the sidewalks, traffic signals, street lights, litter containers, parks, buildings, and things that are underground, the sewers and the storm drains. So I want to talk about two pieces of vocabulary, and then we can delve into a little bit more this afternoon. The first one being service requests, and the second one being work orders. And these are two different things in our mind as a city operational agency, Public Works. A service request is when you, the member of the public, says, hey, we have this problem, we want something done about it. And again, it could be all those different things, illegal dumping, graffiti, tree trimming, et cetera. And a work order is when we send a crew out and actually do the work. And this distinction is pretty important because not every service request leads to a work order. There's some things we are simply not funded to do, and it just doesn't get done. And there's some things that we do proactively that never starts with a service request. But these are kind of the two things that I want to keep in mind and talk about the service request workflow. We track all these things in another piece of vocabulary, a computerized management system, or a CMMS. Could call it an asset management system, could call it a work management system. We're going to call it a CMMS. And we use a particular product called CityWorks, which is a GIS-centric application. And thinking back a few slides ago with all those trees and streets and buildings and parks, everything that we do has a location. And so that's why the GIS-centric piece is so key to us. I mean, everything we do, we're doing somewhere in the city. Pretty much everything that Public Works does, except for fleet maintenance, has a geographical component. So just a little more, our call center is in the city of Oakland. It's actually part of Public Works. In other cities, it might be a separate 311 under some other organization. But in our case, it's part of Public Works, and they get about 36,000 service requests a year. And we take care of about 60,000 work orders. So again, you see the difference between those two things. These numbers have both gone up since I even put this slide together 2 months ago. We're about 37,000 service requests and 65,000 work orders last time I looked. Okay, so the life cycle. So the first thing that happens is somebody makes a request. Now in this particular picture, we have someone making a request via phone, the most traditional way. But they could also email us, they could use our website, and we have a new smartphone application, which I'll talk more about this afternoon, called See-Click-Fix. Those are the 4 ways. The point of this slide really is that all 4 of those ways send it to the same place. And all 4 of these ways result in us looking at that issue the same way. So you don't get to go to the front of the line by calling us. You don't go to the back of the line by emailing us. We treat it all the same. That one in the lower left-hand corner is a screenshot of See-Click-Fix, which we'll be talking about later this afternoon. So we get that call in at our call center, and the call center is going to create a service request. And they're going to create it in that CMMS, that CityWorks computerized maintenance management system. And when they create that service request, it's going to be assigned to a supervisor. This is all within that same system. The supervisor then takes a look at that and decides if we're going to do some work to address that issue, and if so, what type of work is going to be done, and who is going to do that work. So he creates a work order, in this case it's a he, and he assigns that work to a crew leader. Crew leader goes out in the field, they get to take care of the job, whatever it might be. And what's kind of different in Oakland than maybe some other cities is it's actually the crew leader who's recording the work that he or she is doing using technology in the field. A lot of cities haven't gotten to this point. So the crew leader is selecting the asset that he or she worked on. So this would be the street light, the traffic signal, the street, the building that he or she worked on. So again, that geospatial piece is very important to us. And of course, what it took to do it, the labor, the equipment, the materials, how much was done. So if it's going to be illegal dumping, how much was picked up. If it's graffiti abatement, square foot of the graffiti. If it's storm drains, it might be the number of inlets that were cleaned over the course of the work order. They also enter the actual start date, actual finish date. He marks it complete, and then the supervisor takes a look at that for quality control, reviews it, and closes the work order. And the way that our system's set up is when the work order is closed, it closes the service request that started it. So the data is flowing now back from the service request to the work order, back to the service request, and ultimately to the customer. So I kind of summarize it on this slide here. First thing that happens is we do get a contact from our customer. Again, there's 4 different ways that can happen: phone, email, website, or the mobile application. Second thing that happens is that service request is reviewed by the supervisor and then ultimately assigned to a crew in the form of a work order. Now I have these little icons for the email. So what's happening in Oakland is when somebody makes that service request, an email is going to the customer, taking it, showing that we have taken it in and that we are aware of it. And the last step, step 5, is when that service request is closed, they get another email to close the loop. In between, the crew leader is taking care of the work, completing the work within that same computerized management system, and then that ultimately closes the service request. So that's a data flow in a nutshell. And this afternoon, I want to get an opportunity to tell you a little bit more about some of the specifics, particularly around the mobile app, and a little bit we've done with transparency, and then we'll have time for Q&A. Thank you.
Thank you, John. Now we come to Jennifer Palka, whom I actually haven't met yet, although we've spoken on the phone many times.
Nice to meet you.
Nice to meet you, Jen. Please.
Thanks. I'll try not to bore you guys too much, so thank you for the help.
Sorry.
I was going to start anyway with just a quick overview of what Code for America is, not to talk about ourselves too much, but because we're sort of unique, people may not know what we do. We call ourselves a Peace Corps for geeks. What we do is we get people, very talented developers and designers from the tech industry, to come give a year of service, and they work in very small teams with city governments. One of the fellows who's taking a year off to do this with us this year is in the back of the room, Matt Hampel. He's working with the city of Detroit. And so I'm going to talk about 2 examples that we have that talk about how data gets used and what data really matters to people.
So I'm trying to get over to
Are we?
Let's
Oh, I see. You just go.
I'm trying to get it on.
Here,
I'm not
I
used
could
to
do
it.
that,
Thanks.
but it's still not showing up.
Let's try again. Keep going.
Just keep going,
I tell you what.
or is it? You know what? Maybe it's down or up.
Here's what we'll do.
Oops.
Can you get it on this?
I could talk without the slides if you
Sure.
want. Here, let me see if it's down or up instead of side to side, and then if that doesn't, yeah, there we go. It's just the other side. Okay. Yeah, I do need to mirror it so I can forward it. Actually, I'll do it here. Hold on. We can just do this. No, this is here. Hold on. Back over here. If I talk myself through, it'll be easier. View presenter. No, I don't want to view presenter tools. I want to view slideshow, and I will just make do. No, it's reversed. All right, you'll do that. I will keep going about Code for America. So we take these folks, we have them work deeply with cities on a particular problem that that city has. They work through a methodology we call the lean startup. Well, we don't call it that. Eric Ries calls it that. He wrote a book about that's called the lean startup. And the idea is that you can want to use these projects as a machine for learning. You want to understand as quickly as possible what is going to work for you and what isn't. And so the fellows, let me catch up a little bit here. 2 down and 2 over is Matt Hampel, who's in the back. Ask him about his Detroit project. These are the cities that we're working with this year. Lean startup process helps us do this very quickly. We have them go to, they have a month of training with us, then they go to their cities for a month. They do hundreds of interviews with people inside City Hall, outside City Hall, understand where the data is critically. Oftentimes it's in many, many places, and they sometimes find out more about where the data is than people who work in the cities. And then they come back and they have a very short time, about 6 to 8 weeks, to come up with a minimum viable product. And the idea there is what's the smallest thing that they can put out that will teach them what they need to know about this problem and iterate from there. All the software we build is open source, so the idea is that you build it locally, but you spread it nationally. We spend a lot of the rest of the year trying to figure out who else has this problem, what other cities in the country have this problem, and who could benefit from the software, or at least even just the approach. The outcomes certainly are the software, but it's really more about an engagement, about fellows learning how cities work and becoming lifelong advocates for government that works, and the people in the cities understanding how a lean methodology can help them attack problems much more quickly. We also do a couple of other things. We have essentially our platform for weekend civic coders, the Brigade. We do an accelerator for civic startups, and we have the platform for understanding what's working where across the country in civic technology. Colin kindly asked me to talk a little bit about how open data can drive better analytics, and I have to say that I did not find a whole lot of examples of that. What I did find, though, that there's an interesting interplay between open data and better analytics that's a little bit more complicated than just the notion that if you put the data out there, people will find great insights from it. Certainly that's what we want, but I think there are more pieces to it, and that's sort of where I ended up wanting to talk about today. Let me explain this by an example from our Honolulu team. I know, we sent a team to Honolulu. Poor Matt stuck in Detroit. We had a team on the beach. They had a great time. I went and visited the Honolulu team. It was a lot of fun. One of the things they found out when they went to Honolulu was that the key problem wasn't in a particular area, as many of our teams find in public works or in blighted properties, but just with the website of the city. So I don't know how well you can see this, but there's a lot of information on the Honolulu government website. And it doesn't really map very well to the information that people are coming to the website to look for. And so they asked themselves, so they're like, what are people actually coming to this site to do? And of course, as we know now, we have the internet. Before the internet, we would say, you know, what is the answer to the question? Oh my God, we'll never know. But now we know because we have these logs. And so what the team did is they went and looked at the search logs for Honolulu.gov, and they found the things people were actually trying to do when they went to that site. You probably can't see very well, but some of the top things, for instance, were on vehicles and driver's licenses. So they tried searching that on Honolulu.gov. You type in driver's license, you get back this. Let's say you click through one of these, you'll get to this. Now, you can keep clicking and you can keep reading. It tells you information about what a driver's license is, whether veterans now can get a new driver's license. It doesn't ever tell you how to get a driver's license. And you can keep clicking and you don't find that information. So they took those top 10 searches and they created custom content that fit those. So for instance, if you type in driver's license to this interface that the fellows built in Honolulu, it's called Honolulu Answers, you get this. It tells you, okay, you want a driver's license, first time or renewal? Those are pretty much the two options if you're looking for driver's license information. And if you click to that first one, it tells you in very simple, clear, plain language how to get a driver's license, with links to the forms you'll need and the places that you need to go to do it. So they've used data, it's not that they had the open data and then they found a solution. It's that they looked at the problem and they used the data to figure out what needed to happen. But they didn't stop there. They only had the top 10 questions at that point. So then they opened up the process. This isn't open data, this is open process. They held something called a write-a-thon. They had, I think, about 60 people, citizens, people who worked in city government, cops, anyone who had heard about it was invited to come to this event. And citizens of Honolulu brainstormed the next 30 questions that were the top things that they came to Honolulu.gov to find answers to. They wrote custom content and they put it into Honolulu Answers. So now, basically, if you think about sort of the long tail, this is getting pretty far down that tail. Most of what Honolulu.gov actually does for its citizens is handled by Honolulu Answers, and not by rewriting a many, many thousand-page website, but by coming at it from the data and taking it from the top. This is some of the hundreds of answers that they brainstormed answering on a wall at that event. So the other way that we're thinking about open data, though, again, is not so much just analytics. I do think that there are good examples out there of putting data out there and letting people find the great insights from the data. But we're also looking at how open data can drive something we call citizen experience. And it's a variant of that term user experience. And it's bringing in a bit of a different discipline to here, but I think it's a really important one. The story I would tell from this year's fellowship is in New Orleans, where they have been struggling since Katrina to deal with the number of blighted properties. The city is doing an enormous amount with these blighted properties, and the citizens simply can't see it, and it's very frustrating. From their perspective, there's blighted properties on their block, nothing happening, suddenly one's demolished, and it's completely opaque to them. It's been extremely frustrating for these citizens groups that are putting all of this effort into trying to rehabilitate their neighborhoods to not have any insight into what's going on with the city's processes. So the fellows went down there, they did their research, they came back, and within about 6 weeks, they put up this thing called blight status. You can type in any address in New Orleans, and you get back a very simple interface that tells you exactly what's going on. You probably can't read that all that well, but has the property been inspected? Has the property owner been notified? Has there been a hearing? Is there a judgment on the property, and is there going to be a resolution? Resolution is generally that the property is demolished in this case. The fellows had to integrate over a dozen data sets to make this work. It's not like they just put a data set up online. And this begs the question to me, if that's what this was not about taking all of the data in New Orleans and making it open. This was about taking the data that they really cared about. And that's why I start to ask the question, what is open data good for? And the answer that I keep coming up with Code for America in the last year is that open data is about making an experience for citizens that makes them care about government. So what would society be like if we felt about government the way we feel about our iPhones? When you have the data there, the data that people really care about, the data that makes them want to engage with this system more, and you put on it this interface that's simple, beautiful, and easy to use, then you get people hugging you. So we had one of the fellows go down and show blight status to the community groups that he had researched with. And they were happy to have the data, but they were more than that. They were enthusiastic. They were coming up and hugging this guy and thanking him for the work that he did. Because in the absence of any other information, citizens will assume that nothing is happening. So open data isn't just about these great insights. Open data is about a connection between citizens and government, and it gives us the opportunity, I think, which is the most important thing to us here at Code for America. Open data lets us live like citizens. It lets us engage with government as a citizen, which means a participant in it. And I hope that's a different perspective that I can share today that's certainly related to the opportunities of big data, but maybe a little bit of an emotional take on it. So thanks so much for having me, Colin.
Thank you very much, Jen. I love this, using the data to understand what it is people are trying to do in the city. I think it's just absolutely fabulous. Yes? Okay. Mary? Yes. So our next speaker is Mary Camero. We'll talk about roles of information in emergency management. While Mary's getting set up, I was mistaken earlier on. Nate Manning will in fact join us, I think after Mary's talk. He's going to join us from Washington by Skype, thanks to the miracles of technology.
Okay, good morning, everybody. I think that some contribution that should be made by the techies in this room is a simpler way to plug your computer in and get the presentation to come up. How many years have we all struggled in conferences with this? I'm going to talk a bit about disasters, and I think the previous speaker actually was a great introduction to what I'm going to talk about, because when we're looking at disasters, we're really looking at cities in crisis. And those cities need to make all kinds of decisions in a very compressed time frame. Their people have to make decisions about whether they're going to stay, whether they're going to go, how they're going to live, whether their job's going to continue. And so we've got to assemble a lot of data that people need. And we have to think about how useful that is. How do we get the information to those who need it? I mostly work in the earthquake arena, but let me just give you a little bit of statistics. I mean, the reason that disasters are such a problem is that buildings fall down, people get hurt. 50% of the casualties in developed countries tend to come from 5% of the buildings. So from the scientific point of view, we need to identify and fix that narrow bandwidth of collapse hazard buildings. But 85% of the casualties are in developing countries. So we also have a huge set of issues vis-a-vis loss of life in developing countries where virtually everything is a collapse hazard. But in general, the other key fact to keep in mind is that in almost every disaster, hurricane, flood, earthquake, in natural disasters, 50% of the value and 90% of the buildings that are lost are housing. Well, why is that? Because that's the bulk of our building stock, number one. But it really begs the question of what is the important piece of information and building information that we have to pay attention to. The housing isn't necessarily what kills people, except in developing countries, not in the US. So we have two different issues. In developed countries, we have the loss of bigger buildings, and then we have the loss of housing. And the combination of those two is a problem to be solved. And we're really asking, how much can any city endure in the course of one of these natural disasters? Now, from the scientific point of view, from seismology, from earthquake engineering, we know a lot about how to understand the events, how big it was, how does it compare to other disasters, we can measure the impact pretty quickly. We can use sensors, we can use LiDAR, we can use satellite imagery. We have great capacity to sort of get the big picture. What we're not very good at are dealing with those kind of messy issues of recovery, as was sort of described in New Orleans, the blighted properties in my neighborhood, or getting from the science to some level of policy. So if we look at, we can do like the population exposure from extreme shaking, we can do this within, 20 minutes of a major disaster, and we can understand where the impacts were on a sort of statistical level. But if we want to understand how do we plan for this event in San Francisco, how do we make the city more resilient, the problem is harder. An organization called SPUR, San Francisco Planning and Urban Research, asked the simple, they've been working on sort of resilience for the city, and they've asked this simple question: what would it take for San Franciscans to live safely in their homes after earthquakes? Well, it turns out that's a really hard question to answer, in part because, the homes are not single-family, suburban houses. They are all kinds of different building types. But equally important, how do we know what the distribution of the losses were? We're actually pretty good at modeling the losses at a sort of citywide level. But I actually spent a summer with some students trying to break this down into the loss of unusable units by neighborhood. And it turns out that this is a really tough problem. It takes a lot of census data, it takes a lot of GIS, it takes a whole series of things. But the bottom line is, and the message for the city is, we have the potential for much greater damage than we even have the capacity to shelter people after an event. And there is no single neighborhood that is immune. There is no single neighborhood that isn't going to have less than 25% of its housing stock lost. And if you take a neighborhood like the Marina, it's more like 50%. So integrating the data is a huge issue, getting it down to that property level. Another example is looking at those collapse hazard buildings, older concrete buildings in LA. We put together an inventory of all of these buildings. We have them mapped. You can click on them and get information about the buildings. But again, it's really hard to find this information. I mean, again, students for 2 or 3 years to actually collect from multiple public data sources. So we can now know, having done all that hard work, that these buildings were heavily built in the 20s and the 60s, which tells us something about their what building codes they were built under. We know the sort of distribution across kind of industrial space, office space, commercial, so the different kinds of users. We've been doing loss modeling. We know that if we retrofit the older pre-29 buildings that are in this subclass, we can reduce the losses by 50% and reduce the death counts virtually to zero. So, you know, this is a tool then that the city can use to target specific subsets of these very hazardous buildings, which are expensive to fix. So if you can figure out which ones are really going to need help, you can do that. It gets even more complicated on the human side. This is a project from New Orleans done by my colleague Doug Allers at Harvard. They looked at sort of case management in the Broadmoor neighborhood post-Katrina, and here the issue is really trying to link the individuals and the households and the property, and much like the example you saw, I mean, they used a variety of tools, a software called Plan Ready that went out of existence, and then some other software. But the real issue is that it's not just sort of getting that geospatial data, but it's Mrs. Jones needs 8 sheets of drywall, and Mrs. Smith's grandmother, you know, needs her medications and there's no place to get them. And it's linking that very micro kind of information to help the people in that community recover and make decisions about their property and make decisions about their lives. And so it's really linking kind of the housing repairs, the volunteers, the locals, the outside NGOs, the services, the programs. It's that kind of effort, and we could do better at this. I'm sure we have the technology to do better at this, but it's really slow and cumbersome right now. And I think my last example is really from Japan. You know, the engineers, the nuclear engineers will tell you after the Tohoku earthquake and tsunami and then radiation release, you know, things, they give you a nice, you know, the radiation spread is 12 miles, right? But that isn't how it, I mean, that's what science tells, that's what an engineer will tell you. But in fact, we know from Esri's work in Japan that the spread, you know, was to the northeast. And how do you evacuate people? You know, we need to know this kind of thing because thousands of lives are at stake. And for the recovery, we need to continue to know this because who gets to go back home and when? All of these issues are critically important, and I think using the data in these ways is very valuable. So let me conclude with just a couple of lessons for urban systems. We need the spatial, the social technologies to link the data on property, on land use, on people. We need to sort of integrate across these realms to bring it down to the human level because that's where the rubber meets the road. So this aggregation of multimodal information, I mean, a term that's probably used in the technology world, but we've got to get it past the big meta kind of level of looking at it from the satellite and down to the level of the people who are suffering from a disaster. And I think we need to develop better inventories for planning and response. We need to be able to use this data ahead of time to make cities more resilient. Thank you.
Well, Nicholas is setting up. I mentioned earlier on Nate Manning of Ushahidi was not going to be able to be with us, but he is in fact going to give his talk now through the miracle. Yep. So he is going to give us his talk now through the miracle of Skype, and Nick is busy setting this up here.
I'm Nathaniel Manning. I apologize if there's a little bit of background noise. I've had to move to try and get a little bit better connection. I am so yeah, as I mentioned, I'm Nathaniel Manning from Shahidi. I'm the director of business development and strategy. And I apologize for not being able to be there in person today. That would have been a lot of fun. Unfortunately, I come to DC. I'm going to be working on open data for USAID in the State Department for the next 3 months as a Presidential Innovation Fellow. All right, let's see if we can get this presentation up for you. Okay, good, it switched it. Okay, so I'm going to dive into this. All right. So I mentioned Nathaniel Manning Ushahidi. I'm going to tell you a little bit about Ushahidi and how, and our relevance to what we're talking about today. So Ushahidi came about, if you remember in 2008, there was an election in Kenya that got pretty violent. And a group of Kenyans living both in Nairobi and abroad, they wanted to be able to know what was going on. All they were really able to do was see what, the few BBC journalists were able to write on the ground at that time. And that's only like 1 or 2 news articles a day. And they said, everyone has cell phones now. Why is it that we can't work together to be able to tell a better story? I want to know, if all this violence is happening on the street that my mom lives on? What's happening on the ground? So they put together Ushahidi, which in Swahili means testimony or witness. And what it does is it allows you to send a message or Twitter or email, and a lot of the different digital channels that you're used to be able to send pictures or texts or even videos now into Ushahidi, which then puts it on a map and on a timeline. So people would say, hey, I just saw this road closed down, or I just witnessed this piece of violence. And it creates this level of transparency and also real-time information. It's sort of the transitory, intangible part of what's happening on top of the brick and mortar layer. And that proved really interesting. It was this crowdsourcing momentum, and people got a lot of different ideas for how to use that. And just exit out. My slides are not showing. Bummer. Okay, let's give this one more shot. Sorry, I'm listening to Nicholas here. We're going to do a little impromptu tech cleanup. So Nicholas, give me. We know he looks like the slides are showing for me, so I'm going to just jump through. The Ushahidi is for interactive mapping, data collection, open source tool. So we made all the software open source, and the mission of the company is to change the way information flows. So if you've heard of Ushahidi, you've probably heard a bit about the disaster response, which is our biggest instances have been in disaster and crisis response. So here we're looking at the Japan and Haiti earthquake maps. Also was used kind of throughout the Arab Spring. The truth is actually that only about 25% of the maps created using Ushahidi are disaster related. However, these are big, momentous worldwide issues. So that's why they get a lot of press and a lot of people contribute to them. And one of the best things about disaster response maps is that they illustrate how the information could be tangible and actionable. So really, changing the way information flows is about changing the way decisions are made. So we have people bringing information from the bottom, and then here you better inform decision makers like first responders, or where they need to go rescue someone, or where food's being given away, and people work together to do that. So the first Ushahidi instance took about 3 days. The next one was we made it open source, as I mentioned, so you could grab the code off of GitHub and put it on your own server, and that took about 3 hours to do. And then we said we want to make it 3 minutes. We want to make it so that anyone can do this. So we built CrowdMap, which the best analogy is if you've ever used something like WordPress, the CrowdMap is like WordPress. WordPress.org is like the Ushahidi open source. CrowdMap's like WordPress.com, which allows you to create a web page without having to know any code, which is pretty incredible when you think about it. So that was the aim of CrowdMap, to be able to do the same thing, allow anyone to be able to create one of these crowdsourcing tools, these crowdsourcing maps, without having to know any code and be able to do it really quickly. So that's been pretty powerful. We launched about two years ago. And, actually, this graph's a little out of date. It's gone up to about 32,000 maps now. There's in 158 different countries in 22 different languages now. We've translated them into. So we've really seen just this fantastic swell of uses. And as you can imagine, it's been in areas that we couldn't even have dreamed of. So some of the most relevant in this case is in citizen journalism. We've had people, this map on the left is called Harassed Map. And sadly, what this is about mapping when women have been harassed, specifically in Egypt. And women can send in anonymously when this has happened to them. And it's been really powerful because there's been a number of interviews with women who have used it, and they're able to say, you know, like, listen, I was never able to tell anyone about this, but now I feel like I'm contributing to a greater cause, a greater group. We're showing it, we're creating this level of transparency that this is a real problem. And that's really powerful. Sadly, it's actually had thousands of inputs in the last year. On the right-hand side, you see a lot of community development type projects. This is New York, and people saying, here, I love this part of New York City, or there's a pothole on my street, or, you know, this is my idea for what could make our neighborhood better. And that's pretty interesting from an urban planner's point of view. So I met Nicholas in a project that we did in Rio, so I'm going to just share a little bit about that. This is one, not a project we worked on, but someone, again, around citizen engagement, wanted to have people be able to say whatever they thought about Rio. They wanted to share their sustainability practices, and or this is what they wanted the UN to talk about. And you can see there was just a swell of engagement around the world. And then often people ask me how Ushahidi stays around if we're all open source. And the way we do is people will hire us to do custom versions of the software. And so one of those custom versions was with EcoCity. We actually did it in partnership with EcoCity and Esri. We built a really interesting custom version down in Rio. And this is where we wanted to be able to bring qualitative information of people, you know, sharing about their neighborhoods. They know the ground. They know where, you know, water pools when it rains, and what they want to see the neighborhood be. And so a lot of neighborhoods, they're getting gentrified very quickly down there. There's building happening. So we went out and worked with one of the faveled communities, had taught them how to contribute, and said, you know, share with us about your neighborhood, and particularly around the sustainability practices. And as I mentioned, we wanted to merge this qualitative information, kind of crowdsourced information from people's points of views, with the quantitative information. So we inputted it and worked with Esri to input it into Esri's online GIS. And so you can see that here. And here you'd be able to compare that information with wind flows and heat maps and all the other fantastic information that Esri has on hand. And that was really powerful. Now we wanted to be able to give this to urban planners and decision makers so that they can make better, more informed decisions by being able to look at what people on the ground are saying without having to go out and interview every single one of them, which is still a good thing, but being able to get the kind of constant information from them as things change, along with all the quantitative information that's out there. So this is where we see a lot of potential, this merger of that data, quantitative and qualitative. As I mentioned, there's just been fantastic. People are mapping corruption. People are mapping energy, even their favorite burger places across the United States. As we've just seen lots of creativity. We're pretty excited about this qualitative, quantitative area. And yeah, one of the mantras of Ushahidi is just try to fix problems. So thank you, Nicholas, for having us. I'm glad I could share. Please feel free to contact me at Nat or Nathaniel at ushahidi.com, and happy to answer any questions for you. Great. Thanks so much, everybody. Sorry for the technical issues, and hope you have a fantastic day.